So today we're going to be talking about divergent boundaries. As you noticed in your set of vocab pictures, hopefully, a divergent boundary is simply a place where Earth's surface is being pulled apart. That's what the word diverge means. So what we're going to be digging into today is what exactly is happening at a divergent boundary and what does it look like on the Earth's surface because the plates are pulling apart. So before we get too far into it, I just want to know where on Earth we're actually talking about. So there's a couple examples I want you to know. And the first one is probably the most famous one, and it is called the Mid-Atlantic Ridge. And shockingly, it runs down the middle of the Atlantic. So if you find this huge island up here, that's Greenland. The small round one next to it is Iceland. And what you want to do is draw a line right through Iceland and then kind of cut halfway between the shoreline of North and South America and Europe and Africa. And it runs down to about right there. And this is one place where the plates are pulling apart. So Iceland is kind of a cool place. It is right on this divergent boundary. So this island is every year getting wider and wider as it gets pulled apart. It's a pretty cool place to visit, I imagine. The next one is called the Juan de Fuca Ridge. It's named after an explorer who explored this area. And so there's a mid-Atlantic or a mid-ocean ridge, right about here off the coast of Washington and Oregon. And the last one's the East Pacific Rise. And the East Pacific Rise is kind of out here in the eastern part of the Pacific, go figure. So there are some examples of divergent boundaries, and I want you to notice something. All of them are underwater. In fact, almost every divergent boundary on Earth is found underwater. So let's jump down here. What are some features that we're going to see if we were looking at a divergent boundary? So I've already added some things to this picture. You can see I put some arrows in to remind us that the plates are being pulled apart. And I drew in some red convection currents down here in the asthenosphere. So remember, this crust up here at the top is called the lithosphere. And down here where there's convection currents is called the, whoops, I spelled that wrong. Let's try again. Asthenosphere. Now, as the lithospheric plates are getting pulled apart, you'll notice I have some magma slowly rising to the surface. And what I wanted you to see is since the magma is pushing up right here, between the fact that it's hot and hot rocks expand, and the fact that magma is pushing up and putting pressure in an upward direction, what's the land do right here? Because you'll notice this is the Atlantic Ocean. Okay, so this is the United States. This over here is Africa, and in the middle of the Atlantic, the land goes up. This whole raised area is called a mid-ocean ridge because it's a ridge, a raised area, in the middle of the ocean. Now, the reason there's a ridge, a raised area, is because, like I said, the pressure from the magma rising and the fact that it's hot makes it expand and go upward. So, as the plates pull apart, magma comes up between them and causes this mid-ocean ridge. Now, at some point, it's got to tear, and there's a word that means to tear, and that is rift. So a rift valley is a valley formed when the land rips or rifts apart. And if you look at the top, you see that V-shaped valley right here? That is a rift valley. So it's a valley on a mid-ocean ridge where the land is rifting or tearing apart. So just to repeat, convection currents in the asthenosphere go apart from each other, which drags the plates apart from each other. When this happens, the land rips apart, magma oozes up in that crack, and it hardens to form rock, and the plates pull apart again, and the magma oozes up and forms rock, and then the plates pull apart again, and the magma oozes up to form rock, and what you find is something called seafloor spreading, which there's a spot for it on the back of your notes. I can show you right now. It is right up here, and I've actually already written it out for you, but basically seafloor spreading is what I just described. As the plates pull apart, the magma comes up, it cools into rock, so it's new ocean floor. Then the process repeats itself again and again and again, and the ocean gets wider. Or in other words, the seafloor spreads. So what that means, let me go back to my original picture, there are some places where the ocean is getting wider. That means there has to be other places on Earth where the oceans are getting smaller, and we'll talk about that next class period when we talk about convergent boundaries. So let me go down to the bottom of the notes and we'll finish this up. So there is a relationship between the distance from the Rift Valley and the age of the rocks and the temperature of the rocks. So, as you can figure, what do you think the rocks are going to be like right up here at the Rift Valley? They're going to be hot, and they're not going to be very old because they just formed. So I'm going to say hot, young rocks are found right there. So what do you think the rocks are like down here? They're going to be cold and old. Now, the reason that's important is these hot ones are less dense. These cold ones are going to become more dense. And when we talk about convergent boundaries next week, the density of these crust pieces are going to be something that's important. So I'm just going to mention now, sometimes ocean floor is more dense, sometimes it's less dense, and you'll see why that's important later. Okay, last thing. I did mention mid-ocean ridge formation. I don't think you need to write anything down, but that's just, there's a mid-ocean ridge because magma is pushing up, and it makes the land go up under the water. Okay, last but not least, sometimes the rifting or the tearing occurs on land. The only place on Earth where this is occurring right now is in Eastern Africa, and it's shockingly called the East African Rift Zone. So if you look at my map, I've already drawn it in. It starts right up here in Djibouti, yes, country right there called Djibouti. It runs down through Ethiopia, it wraps around this lake, Lake Victoria. There's 2 divisions to it, and then it kind of branches here. This whole line that I drew is a rift zone, which means it's trying to pull apart. Now, it's not very active right now, and so it's not really moving per se. Like GPS doesn't show us it moving apart, but the land right here is very thin. There's lots of volcanoes and there's magma coming up. So we know it either is becoming a divergent boundary or it tried to form one and then just failed and stopped. So either way, we know it was trying to. There's volcanoes there. There's lots of magma coming up from the mantle in this area. And it's the only place on land we know of where it's happening right now. And it's called the East African Rift Zone. And that is all I've got for divergent boundaries. So please make sure you jot all this stuff down on your notes and then use your notes as you try and fill out today's worksheet. As always, if you have questions, please just let me know. Contact me on Google Classroom or shoot me an email. I would be glad to help you. Hope you're having a great day.